One cluster with two load balancers, one for internal traffic and one for external traffic? Sounds good to be true. So, let's build it. I'm Garrett, and this is TheFatRat. So in this video, we're gonna set up our load balancers for our cluster that we have been building. And we're gonna set up two load balancers, one for internal traffic and one for external. Now, let me show you what we're gonna build. So this is what we're gonna build. I made it quick, so it's very simple. We have our cluster here. What we're gonna do is we're gonna set up two load balancers in our cluster. One is for the external traffic, so all the traffic that comes from the internet, and that's where we keep every app that we're gonna load over to the internet. So anything externally accessed. But we also have tools and stuff we don't want to expose to the internet. And that we are gonna route over the secondary load balancer for the internal traffic. So all my previous videos about installing a Kubernetes cluster have led to this moment. We're ready to set up our load balancers so we can finally interact with our cluster in a nice way. Now, the previous videos I created were about certificates, so creating your own certificate authority for your own local network. For our external traffic, we're going to use Let's Encrypt. We also set up the cert manager and we set up a repository for our deployments with the GitLab Kubernetes agent so that we can easily reproduce our entire basic setup of our cluster if anything goes wrong or we need to recover. Now, let me show you how this works and how we're gonna deploy this. So we're back with the repository we created in the past few videos. So this is our K3S repository where we keep our deployments. You can check the link down below to find it and to go through it. Now, let me run you through the entire configuration what we're going to deploy. So we're going to deploy traffic. What we're going to do is two setups. We have a traffic cert manager. This is a project that I took from GitHub and expanded a lot on. And this will give us interaction from something specific for traffic. So let me tell you what's going on. So the standard cert manager is able to provide you with certificates that we loaded earlier for the ingress route resource of Kubernetes. But traffic also has something called an ingress route specific for traffic. And this one cannot automatically, by default, get certificates from Cert Manager. So that is what Traffic Cert Manager will do for us. So the Traffic Cert Manager is loaded from my GitHub. So that's the repository. We're going to deploy it as Traffic Cert Manager, namespace traffic. We got the chart, we got the version, install, and the values. And when it comes to the values, here is something that is already specific to our amazing deployment of two load balancers. We're going to tell it to only scan specific ingress class filters, meaning that it will only scan any ingress that has this as an ingress class on there. So that allows us to limit it. So if you need to run any more load balancers, it will not interfere with those. So that's the traffic cert manager. Now, then we have traffic here. Well, I split traffic into several options. I have created a CRD deployment, and the reason for that, it allows us to install the traffic CRDs, the custom resource definition, so that those are installed. Then we can load the traffic cert manager, and then we can install traffic for internal and external load balancing. So we're going to install the CRDs before we're going to install traffic cert manager. So the traffic CRDs are loaded from the official traffic repository, the chart, the version, install, and the values. And the values are just a few basics. Now we're getting into the fun part, our two load balancers. I am going to go with the internal one first because the external one is a tiny bit different. So let's run through it. It loads traffic from, of course, the standard traffic repository. So currently we're using release 35.2. We're installing it to the traffic namespace. Installed force, yeah, true. It's all fine. And values. Now, here's where it gets interesting. So let me run you through it. So what we're doing is we're running two replicas, meaning we're running two instances so that when one goes down, the other one automatically takes it over. That allows us to restart a node for maintenance without it having any impact on our traffic. We're doing a rolling update, max unavailable one, so it will go one new one, take one down, one new one, take one down. Perfect. Here are some standard global arguments about version check and do we want to send anonymous data. So that I disabled that. Then we go to ports. So I changed the default port configuration. Just this is how I like it. The web port, so that's HTTP traffic, will be port 8000. This is just for the pod, not the service. We're gonna go into that later. And we're setting it to redirect. Now, here's the trick. There's something special in here, and that's a priority. More on that in the next video, because the next video is going to be very cool. But what we're doing is we're redirecting all our HTTP traffic to HTTPS. That's pretty awesome. Then a web secure, that's port 8443. And we're also enabling the new HTTP3 protocol. Then we're having traffic. So this is the API of traffic itself. It's also where the dashboard runs. Now we're getting into the first special part, which is the ingress route. So the dashboard, yes, we definitely want the dashboard enabled. And we're gonna run the dashboard at internal.traefik.k3s. Cool part about it, in my DNS, in my network, I set everything for star, for wildcard, .k3s, and I gave it the IP number for my internal load balancer. So any domain I type in my browser, my computer will go to the DNS of my local router and see, hey, I have to go to this IP, which will be the IP of the internal load balancer. And we're gonna have entry points and we're allowing web and HTTP in there. And here's the first special part. And that's the ingress class. And that is in traffic internal. This is also directly linked to traffic cert manager so that it can find ingress routes and it can issue certificates for it. So this causes it to link together. And we're also giving it the cert manager IO cluster issuer K3s-CA. So that's the cluster issuer so that it can give out certificates for this. So this will cause it to go to traffic cert manager. That will trigger to the certificate creation in cert manager itself by using the K3s-CA, and then it will create a certificate for internal.traffic.k3s. And here, as you can see, we're gonna call this internal traffic cert. Then we put a domain in there, and that's it. Now, services, we're gonna set it to traffic policy cluster. We wanted this to become a service that uses a IP load balancer class. So in this case, we're using the kubevip. The kubevip that we installed by default with our cluster deployment. And that gives us the ability to provide IP addresses. So kubevip manages in our setup a range of IP numbers, which we configured in our configuration in Ansible. So it can just give out an IP address from this range. And it will bind to one of the nodes, etc. And it allows traffic to flow in. And here we say also the ingress class will be traffic internal. Then we are enabling the standard Kubernetes resource, custom resource, so the standard ingress class. And so this is the Kubernetes CRD. This is the default from traffic. So this is the standard Kubernetes one. Also, traffic internal as class, which means it will be linked and binded to this load balancer. Standard logging, and here are some final tricks. Affinity and topology spread constraints. And what I've done here basically means that we're giving a topology name on Kubernetes IO host name, and we're putting in traffic instance name. This allows it to be spread out across different hosts. This enforces that our load balancer, because we're running two of them, not only two for internal traffic, but also two for internal and two for external, this will enforce it not to run on each node. For example, this will enforce that the two internal load balancers will not be on the same node. And that's it. Now, that's the internal one. Now we go to the external, because the external will be a little bit different. And let me explain why. So we have the traffic coming in from the internet, our external traffic for the services that we're hosting and that we want to expose to the internet, right? But we also have a traffic dashboard. And that's definitely something we do not want to expose to the internet, right? So what's cool about this is that the dashboard of our external load balancer will be served by our internal load balancer. So that's pretty cool. It means the traffic, the HTTP comes in, but we can view our external load balancer, the dashboard from traffic, through our internal load balancer, so it is not exposed to the internet. So yeah, that's pretty cool. So for our external load balancer, same stuff, literally the same as the internal load balancer. The only difference is the name. We're calling this traffic external. Now we're going to go into the values. Same thing, replicas, same update strategy. And here's some difference. We're having the standard anonymous data, the check new version, but now we're also sending API dashboard true and API insecure. Don't worry, it's not fully insecure. Let me explain why. We're doing the same thing with the ports, redirection from HTTP to HTTPS, setting up the web secure, setting up the port number, HTTP3, the traffic port to 9080. But here's the difference. So the ingress route for the dashboard, we fully disable that because we don't want that to be exposed on the internet in any kind of risk, etc. So we're fully disabling that. Service, same thing. We are requesting an IP number from KubeVip, an IP number of our actual network. Ingress class is traffic external, which means any ingress or ingress route that has the class traffic external will be picked up by this traffic external load balancer and loaded into the traffic and create the route, etc. automatically. Same kind of logs, as you can see, and the same kind of topology and affinity, ensuring that the two instances of the traffic load balancer will not be on the same node. Maybe you've caught on, but I'm doing something special here. I am actually binding it, in this case, to the traffic instance name, doing the same for the internal load balancer. The reason for that is that without this tiny change, it will not allow a internal and external traffic to be on the same node, which is allowed. Otherwise, you would need more nodes because we're running multiple instances, etc. But an internal and external traffic is allowed on the same node, because if we still reboot that node, we still have one of them on another node. So here we come into the special thing for the external load balancer. And what we're doing here is we're creating the resources so that the internal load balancer can access the external load balancer dashboard. So how are we doing that? Well, first we are defining a service, and we're creating a service in Kubernetes, and we're calling this the traffic external API because that's what we want to access, right? And we're giving it a name, we're giving the service an instance, we're giving it a cluster IP. We're calling the ports, it's traffic 9080, and the target port is 9080 TCP protocol. And here's the trick, the selector. And it means that it will create a service in our Kubernetes, and it will link itself to a service called traffic, where the instance is called traffic external traffic. And that's the name that the external traffic instances will get. They will get service dash namespace. So that's why it's called traffic external traffic, because they're both in the traffic namespace. If I would put internal here, this service would be linked itself to the internal load balancer, which is not what we want. And from earlier at ports, you can see both are running on 9080. So basically, this service will make a link to the traffic API port for the service traffic external. Final thing what we need a route. We need to tell the internal load balancer to route it. So And we're doing that in this case by creating a ingress route. The reason we're doing that is it will immediately also check if our traffic cert manager that has to redirect this custom type resource, as you can see, it's of the API version of traffic itself, and that it will be picked up by traffic cert manager, redirected to cert manager, and issue the TLS certificate. So 2 birds, 1 stone, right? Metadata, we're calling this the traffic external dashboard. Namespace will be in traffic, this route. And here annotations, ingress class. And we're calling it traffic internal. That means that this route will be picked up by our internal load balancer. So this will cause the internal load balancer to pick up this route and therefore route to the surface to the instance of the traffic external instance to its dashboard. So we're allowing HTTP and HTTPS, and the earlier routes will automatically redirect HTTP to HTTPS, right? And we're calling this route to be available at external.traffic.k3s. And here is the glue that links this route to this service. And that is services go to the traffic external API that we created here at the top, namespace in traffic port traffic. So this route will then direct to this service, and this service will then connect to our instance of the traffic external. Finally, in our configuration overview is how are we going to load it? Well, there's a trick to it. We create a helm file configuration. This is the helm file configuration where we simply say, hey, you're going to load these helm files in this order. So we're loading the CRDs, then the cert manager, then the internal, and then the external. Reason why we're doing it in this order: at the external, what you just saw, we're creating services, and the internal might need to be available. So that's why we're doing it in this way. And finally, we're having our Kubernetes agent, what we set up in previous episodes, to have this deployed. I create a new input deployments. The reason for that is so that we still can deploy our cert manager individually like we wanted from our previous videos. I also create a variable image so that we can update the image in one place. Update the cert manager to use this image variable. And here's the new job: deploy stage deploy. Use context. So that's the script that allows us to connect to our GitLab Kubernetes agent. And then we're giving it, hey, just deploy this root helm file that has the different helm file paths and deploy. Finally, a little rule, and that will say that, hey, if the deployments that by default is true and we are on our main branch. So if you're playing with additional branches, you do not automatically deploy. And that's it. This allows us also that if you turn in your pipeline, you run it from the web UI, you can actually turn cert manager on, turn the deployments off, and then you're only installing cert manager. That's our configuration overview. Looks complex, but if you not follow it, just rewatch it. It makes sense. Just watch it step by step. Now, let's deploy our load balancers. One cluster, 2 load balancers. Let's deploy it. Let's jump to our repository with our deployments. Link is also down below, so you can easily clone it and copy the configuration for yourself. Here we are at our repository, and what we're going to do is we're going to go to build pipelines. So we're going to create a new pipeline, and it picked up our new input variable. So we're going to say cert manager, no, false, and deployments true. And then we're going to say new pipeline. So that just got started. Now let's jump over to our cluster. Here we are. So in a few moments, we should actually see the traffic cert manager coming online, then the traffic internal load balancer, and then the traffic external. Oh, and here's the first one. Cool. So the traffic cert manager, 2 instances, one on node 5 and one on node 7. Perfect, just as we wanted. Here is the traffic internal. Perfect. And here is the external. This is absolutely fantastic. So by the way, these are the pods, right? Now, what if you can, by the way, in K9S, you can actually use the column to go to different sections and different parts of your cluster for management. So we're gonna do column. Let's inspect the surfaces. So column and then surface, enter. And here we have our services. So as you can see, we have our traffic external, that's of type load balancer, and it received an external IP from kubevip number 80, just from our config. Then we have our service internal, and that received our internal IP address from kubevip, and our manually created service traffic external API that allows us to flow the dashboard from internal to external so we do not expose it on the internet. And as you can see, it goes to traffic 9080. So let's go into this one. And as you can see, it picked up the selector. So this service goes to either one of these paths. That's absolutely fantastic. You know what? Let's find out if we can access the dashboard. So what we're gonna do is we're gonna jump to our browser, and I created a DNS that says in my network everything for wildcards. So asterisk.k3s go to my IP address .60, the internal load balancer. And there it is, our internal traffic. If you go to HTTP, you can actually see here that our internal traffic has picked up the ingress route we created in the external deployment. One for HTTP because there's no TLS shield here, and here one with HTTPS, and it goes traffic external dashboard. This looks so cool. Let's go to this route. And it goes to service. It picked up everything, and as you can see, it gets the whole IP address of the pods with the correct port. Wow, straight out of the box. Now let's see if we can access our external traffic dashboard. So that would be external traffic.k3s. Well, it has also, as you can see, a shield because we have not yet added our certificates to our local machine. I'm going to show you that in the next video. Spoiler. So we're going to just accept this certificate because we have not loaded our certificate before yet. And here we have it. This is the dashboard of our external traffic that we are accessing through our internal load balancer. So if we go to HTTP, as you can see, it has not picked up the route. It's not exposing anything. This is pretty amazing. So in this video, you saw me set up 2 load balancers with redundancy, one for our internal traffic for all of our tools, so that we do not expose them needlessly to the internet, and one for our external traffic. And in the future, we're gonna build on top of this, we're gonna add Let's Encrypt and a whole lot other amazing stuff. I hope you enjoyed this video. Please comment, like this video, subscribe. It really helps me out. And I see you in the next video. I'm Garrett, and this is TheFatRat.